the use of second equation in its real and modified form to solve the problems. Just consider the equation which we have acquired from basic definitions of motion. As you all know, the equation of kinematics to find the displacement of the particle at any time interval. Equation number second of kinematics, it gives displacement of the particle after time t. Say, motion starts at time t equal to 0. Then displacement of the particle as a function of time and initial velocity u can be written as ut plus half at square. This equation is written here in its real form. No doubt, as we have discussed earlier while proving these equations, while obtaining these equations, we have discussed that this equation can be modified in the form s equal to u plus v divided by 2 into time. Here u plus v divided by 2 gives us average velocity in the given time interval t, where u is initial velocity, v is final velocity, velocity at any time t when we are calculating this displacement. So average velocity in case of constant accelerated motion, u plus v by 2. So the displacement of the particle in this time t, we can write it as average velocity into time taken. So u plus v divided by 2 the average velocity and t the time. It can also be written as in its one more modified form, s equal to vt minus half at square. Here v is the final velocity. In this case, we do not require any detail of initial velocity. We just have the velocity of the particle at that time at which we are calculating displacement. Now, what will happen here? When to use the real form, when to use this modified form, or when to use this average velocity into time form of the displacement, we require the basic descriptions of motion to which particle is undergoing. Let us first consider a special case. We are talking here about the case 1. If details of initial and final velocities are given under the condition of constant acceleration, then what we must do? We must use the modified form. We have to find the displacement as using the formula u plus v divided by 2 and multiplied by time t. Here, consider an example. In this example, I am just considering a particle which has been thrown vertically upward and it reaches at its maximum height in the time 3 seconds. A ball is slided over a smooth inclined plane with a speed 20 meters per second. It attains its maximum height on the incline in 4 seconds. Then find the displacement of the ball. What we have to do here? Here we have been given the initial velocity u, which is 20 meters per second. Acceleration is not given, but in this question we can consider acceleration to be constant. So for constant acceleration, average velocity can be defined as initial plus final velocity by 2. And here, in case of the ball, when it reaches at its maximum height, its velocity will become 0. As velocity, final velocity is 0, initial velocity is 20 meters per second, and the time interval which is used in this motion is 4 seconds. So we can get the displacement of the ball just by applying this form of the equation of motion number 2. We get 20 plus 0 divided by 2 into time taken, which is 4 seconds. So the answer for this displacement S is 40 meter. Means in this case the ball moves up to the distance 40 meter on this inclined plane. You can see here we have not used the acceleration term. What is the acceleration here? We don't know. But we know at the maximum height its velocity becomes 0, while initial velocity is given to us, which is 20 meter per second. The time interval used is 4 seconds, so we can easily get the displacement of this ball in its ascending is 40 meter.